Okay, so in this slide you see different probability distributions or binomial probability distributions and their respective cumulative probability distributions. And specifically, this is for the number of trials, for a number of trials of 20, so like 20 coin tosses. And then we want to visualize, what's the probability that when you toss a coin 20 times that you get 0 head, 1 head, 2 head, 3 heads, and so on. But here we also play around with different probabilities. So we include basically non-fair coins as well. And then we can see how that changes the probability distribution. So I will do the same thing now in Excel, except for I will not do it for 20 coin tosses, as you can see here, but for 100 coin tosses. And once you have seen how I do that in Excel, it should be easy for you to replicate the same thing that you see on this slide yourself. So yeah, let me go to Excel then. So first I create a column and I call that successes. And specifically, the number of successes, if I have 100 coin tosses, they range from 0 successes to 100. So I create a column and go to Home, Fill, Series, Step Value 1, Stop at 100. Okay, so now let's create a column for the probability. And the probability, we can use the formula for the binomial distribution, equals binom.dist. So number of successes I'll take from the first column. The number of trials is 100. The success probability is 0.5. And I don't want it cumulatively, so 0. Well, so if I flip a coin 100 times, the probability that I get 0 heads is pretty slim, but could happen. But now what I did in this formula, I entered manually the success probability of 0.5. What I want to do is I want to make that basically a variable so that I can just change that value and everything else adjusts. So what I do is I quickly insert here a row, maybe another one, and I call that here success probability. And then we can make that an input variable, and I'll just say this is 0.5. And maybe let's center it, and also maybe format it and say, well, this is actually an input. So instead of hard coding the 0.5, I'll just pick it up from there, and then I can always change it easily. So I'll just say this value is actually picked up here, and then I need to fixate it with F4. Okay. And now I can just copy down that formula. Okay, and you see if you scroll down, so yeah. The most important thing that you can see is that the sum of all those events is always equal to 1. So all possible events, all possible probabilities need to sum up to 1, which they do. So in other words, the probability of getting 0 heads plus 1 heads plus 2 plus 3 plus 4, all those individual probabilities need to sum up to 1. So in other words, the area underneath the probability distribution will be 1. So now let's take a look at this probability distribution. Insert recommended chart, and yeah, let's do this one here. So you can see it already looks a little bit like a normal distribution. And let's put it up here. So let's say I want to add here a line outlining that essentially column chart. So in other words, if I want to add something which looks like those red lines, then I would have to duplicate that result, and I just call it probability maybe outline, and then I just replicate the same values, but I define it as a different, maybe I can make that a little bit smaller here. Okay, so it's exactly the same numbers, but now what I will do is I will just add data. So we go to select data, and I add the probability outline, and then I read in those values. Then I have to make sure that the horizontal category axis, it doesn't start at 1, but it actually starts at 0. So we read those in. And now we have two series that we display, and they of course look very similar. So now what we can do is we go to combo chart. So we say change chart type. And I say the probability, that still stays the clustered column, but the probability outline, I want that to be a line. You see, then we have here like an outline. Okay. So next what I can do is, you can see what happens is if I change the success probability to, let's say, 0.1, then the curve shifts to the left, and if I go, let's say, 0.8 or so, it shifts to the right. That means that the highest probability is now at around 80, or exactly 80, if it's 0.8. Okay, this here is the probability distribution. If we want to look at the cumulative distribution, we also add two more lines. So now maybe I just can already put that here. So now I add another column, and I call that cumulative probability. And we also have another column that we call cumulative probability outline. So the first thing I can do is I can use, of course, the Excel formula. Equals binom dot dist, open parentheses, number of successes 0, number of trials 100, success probability, we'll pick that up here, fixate it or anchor it, F4, But now it's cumulatively, so we put in a 1 or true. Okay, it's a pretty small number again. Actually, let's format it like the other ones. Okay, very small. So now we copy it down, and you see we have now the cumulative probability. And at the very end, at the 100th observation, the cumulative probability needs to be exactly 2, correct? 1. And that's what we see here. So now I entered here the formula. Another way of doing it is to sum it up manually. And I just say cumulatively, the probability of having 0 successes is just like the probability of having 0 successes. But now what the cumulative probability distribution does, it always adds to the previous observation cumulatively the next one. So plus the next one. And now we sum that up. It's the same thing as the formula, and you see we get exactly the same numbers. So now we can also generate the formula, or we can also generate a probability distribution for the cumulative functions. So I just need to highlight those two because one will be the columns, the other one will be the outline. Okay, now we insert and now recommend the chart. And we can click on this one here or that one and then change it. So now we have twice a line chart, but I want to change that again to one being a clustered column chart and the other one a line. So we go to combo, cumulative probability, clustered, outline. Okay. So now we have the two charts, and we don't need here a chart title. We know that this is the cumulative one, and maybe want to group them. Maybe now we have them all in one. And I can make it a little bit bigger. Okay, so now we can see what those functions look like. So now let's say if we go back and we have a probability of 0.5, it becomes very symmetric. That means that the maximum, that the most likely outcome is that when we flip a coin 100 times, that we get 50 heads. But the probability of getting 50 heads is only 7%. It's not 50%. And if we had a probability of, let's say, 0.9, so that means it's a very unfair die, it gets ahead 90% of the times, then the most likely outcome would be 90. And you can see how the entire distribution is shifted to the right or to the left. So, and again, the area underneath the distribution, so that the sum of all those pillars that you see here, the sum of all those pillars is always equal to 1. And cumulatively at the 100th trial, that's why we get a 1. So what you can learn from the binomial distribution, and that's identical for all distributions is that the probability mass under each probability distribution, the area underneath it, is always equal to 1. And the cumulative probability distribution essentially already sums up those probabilities for every number of observations. So the cumulative probability of, let's say, 50 is the probability of getting 0 heads, or 1 head, or 2, or 3, or 4, or 5 until you reach 50. Okay, so I hope that this is clear. And if you want to replicate it in Excel to get the same thing as here, you can do it with 20 now, and you should have the skills. All right, let's just stop here, and in the next video let's still have a few final words on the binomial distribution.